Good morning, good afternoon, guys. This is going to be the video for assignment number 17. This is actually the last set of notes that you're going to take for this class. It's the last set of notes and video that you'll watch. The next assignment is practice problems. Then you have a little quiz at the end of this week. And then after that, you're going to start reviewing for your final exam. So you guys are almost done. You have just a couple more weeks left of school. I am a little bit emotional as I make this video because I'm just thinking about how excited you all must be by now and how much I must miss you all because this is now like this would be like the third week that I've been at my new job and not being with you all in class. But I am so happy for you all, and I can't wait to see you all at graduation. Okay.
Now let's see how we can solve a different type of nonlinear inequality. What about solving a rational inequality? Step 1, solve for values that make all denominators 0. Step 2, solve the related equation. Step 3, separate the number line into regions with the solutions from steps 1 and 2. Step 4, for each region, choose a test point and determine whether its value satisfies the original inequality. And then step 5, the solution set includes the regions whose test point value is a solution. Check whether to include values from step 2. Be sure not to include values that make any denominator 0. So notice this is an inequality and it's a rational inequality. One of the most important things is to be able to identify rational inequalities. Now that we've identified this as a rational inequality, let's solve this inequality. Remember our first step, to include on this number line any numbers that make the denominator 0. Notice by inspection, 4 makes this denominator 0. Since it does, I will include 4 on my number line. Now we'll look at the related equation and whether before we were looking at this equation or the inequality, 4 is still a value that makes the denominator 0. Let's now, though, move on to the next step, which is to solve this equation. So how do we solve this equation? Well, we look at this equation, we notice it's an equation with rational expressions. The LCD is x minus 4, and we multiply both sides by the LCD. So the left side by x minus 4, and the right side by x minus 4. Notice on the left side, the x minus 4's divide out, and I have x plus 1. The right side, 0 times x minus 4, is simply 0. And then solving, we'll have x is negative 1, another number on the number line. And now, just as for polynomial inequalities, now we check these regions in the original inequality. Now, by the way, I know I have 4 on this number line, but it doesn't mean I'm going to include 4 in my solution set. Can you agree that x cannot be 4? So it's not going to be a solution, but we still need it on the number line. Check any number less than negative 1, check negative 100 if you want. Let's check, say, negative 2, and I'll have negative 2 plus 1 over negative 2 minus 4. We just want to know, does any number in this region make this a true or false statement? Negative 2 plus 1, that's negative 1, and in the denominator, that's negative 6. So is that a true or false statement? Well, negative 1 over negative 6 is 1/6. 1/6 is greater than or equal to 0. So this region is in the solution set. It is a solution region. Check any number between negative 1 and 4. I will check, I'll check 0. So 0 plus 1 over 0 minus 4, true or false statement. That's 1 over negative 4, true or false. Negative 1/4 is not greater than or equal to 0, so this is a false statement, which means that's not a solution region. And then I'll let you check something greater than 4, check any number greater than 4, you'll find that it is a solution region. By the way, if you're wondering, you might want to experiment a little bit around too and see if these don't alternate again as what we were talking about with polynomial inequalities. Just be careful when you have any kind of a factor occurring more than once. Now, let's write down the solution set in interval notation. Normally, with greater than or equal to or less than or equal to, all the endpoints of the intervals get brackets, except this can never get a bracket. We cannot include 4 in our solution set. So let's write things down from left to right. Negative infinity to negative 1. I will include negative 1. It did not come from the denominator. Union 4. I will not include 4, so I'll put a parenthesis and then to infinity. And you can check a few numbers in each region. These numbers will all make this a true statement. At this time, practice solving all types of nonlinear inequalities. Just remember, if your inequality is less than or greater than, all of your numbers get parentheses, less than or equal to, greater than or equal to, everything gets a bracket. All of your endpoints of your intervals get brackets, except any numbers that came from the denominator of rational inequalities.
All right, guys, that's it. No more videos, no more notes. You're almost done with the class.